Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 6, in which I will discuss about events and total probability. In our previous lecture, we have discussed about sample space and event. Also, in this lecture, we would like to repeat about the sample space and event. We know that sample space is a set which is the collection of all outcomes of a random experiment. The sample space is denoted by S, and event is a subset of a sample space. Event is denoted by E. Event is subset of sample space. By an example, we will try to understand this. If we toss a coin, outcomes are head or tail. We collect all outcomes, head and tail, and make a set S. This set is called a sample space for the random experiment. Throwing a coin. Here, let A is a set containing head only, and A is subset of S. Then A is an event. Similarly, if B is a set containing element only T, tail, and B is a subset of S, then B is an event. Since phi is a null set, which is subset of any set, therefore phi is a subset of S. S is a sample space. Phi is a subset of a sample space, then phi is also an event. S is the subset of itself, therefore S is also an event. This event is called sure event, and phi, the null set, is called impossible event. In axiometric approach of probability, we have already discussed that P is said to be a probability if P is a real valued function whose domain is power set of S, means power set of sample space, and codomain is set of real numbers. Therefore, P is a function whose images are real numbers. Also, if E be an event, that is E is subset of sample space, and E belongs to power set of S, then PE greater than equal to 0. The functional value of E is greater than equal to 0. Number 2, PS equal to 1. Image of S equal to 1. If E and F are two mutually exclusive events, that is E intersect F equal to phi, then P E union F equal to PE plus PF. By an example, we will try to understand this. Since in the case of throwing a coin, the sample space S contains elements H and T, and power set of S contains all subsets of S. Let the set containing H is A and image of A equal to half. Set containing element T equal to B, image of B is half, and image of S equal to 1. Here A and B are mutually exclusive, because if we take the intersection of A and B, then we will get phi. And here it is obvious that PA equal to half, PB equal to half, PA plus PB equal to half plus half equal to 1. A union B equal to S, and PS equal to 1. Image of S is 1. Therefore, PA union B equal to PS, A union B equal to S, and PS equal to 1. And here we see that 1 equal to PA plus PB. Since here we see that A intersect B equal to phi, means A and B are mutually exclusive events, then PA union B equal to PA plus PB. Just we have seen that if A and B are mutually exclusive events, that is A intersect B equal to phi, then PA union B equal to PA plus PB. Now question is that if A and B are not mutually exclusive events, that is if A intersect B is not equal to phi null set, then what will be the value of PA union B? Now we solve this. Since each event is a subset of a sample space, therefore all events are sets. We will solve this with the help of set theory. Let this is set A, this is set B, and their common place is A intersect B, and this side is A minus B, this side is B minus A. Here it is clear that A equal to A minus B union A intersect B, means union of these two parts make A. This is number 1. Since A minus B intersect B equal to phi, therefore we use this formula P A minus B union A intersect B equal to P A minus B plus P A intersect B, and this union is A, implies that PA equal to PA minus B plus PA intersect B. This is number 2. Again, set B. Set B is the union of A intersect B and B minus A. A intersect B union B minus A. And since A intersect B and B minus A are mutually exclusive, there is no common element. That is, their intersection is phi. This is number 3. Therefore, with the help of this formula, P A intersect B union B minus A equal to P A intersect B plus PB minus A implies that P, this is B, equal to P A intersect B plus P B minus A. This is number 4. Since A minus B, A intersect B, A minus B, this part, this is A intersect B and this part is B minus A, are mutually exclusive. Therefore, P A minus B union A intersect B union B minus A equal to P A minus B plus P A intersect B plus P B minus A, and A minus B union A intersect B union B minus A equal to A union B, P A union B. This is number 5. Now, P A plus PB. PA is PA minus B plus P A intersect B plus PB is PB minus A plus PA intersect B, P B minus A plus P A intersect B. This is equal to, here we see that from 5 P A minus B plus P A intersect B plus P B minus A is P A union B, P A union B plus P A intersect B implies that P A union B equal to P A plus P B minus P A intersect B. This is the required result. P A union B equal to P A plus P B minus P A intersect B. This is called the formula for total probability. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.